All right, and we are set. Make this a bit bigger so you can see what's happening. All right, open up data course Zon. Control O to open code examples, ggplot intro.r. This is essentially where we got, down through plot number 4. So let me show you a little trick. Showed Lacey this the other day when she had a question. We met one-on-one. But there's a secret little button combo that tells RStudio to run everything in your script from the top down to where your cursor is, which is pretty handy. It's Control-Alt-B for everything before your cursor. On a Mac, it's Command-Alt-B. So I hit Control-Alt-B, and you can see down here in my console, it just starts doing everything in my script up to this point. Why is this so handy?
Isn't it so it allows you to check all that you have if there's any errors? Like
Yeah,
it works.
exactly. It's definitely more than just the convenience of kind of running everything when you reopen a project you've been working on. This lets you make sure that everything's in the right order. Okay, so a lot of times in R, we'll be playing with stuff and we'll copy and paste and move things around because we're using it interactively. But we need to keep in mind that our script has to run from A to Z in a certain order, and this will throw errors if stuff's out of order. So if I've got P4 plus facet wrap right here, if I'm doing this, but I haven't defined P4 yet, it's going to give me an error. So if I move that down here, just for some reason, that's how I wrote it, everything's screwed up. Okay, so Control Z, Control Z, Control Z. But there we have it. So Control Alt B, remember that one. It's a nice little sanity check. Okay. So let's take a look at this plot. Can you just describe for me what facet wrap squiggle state did for me?
It separated the condensed plots like into the same plot, but into like giving each state its own.
Yeah, giving it its own. That's definitely a good way to look at it. It is dividing up your plot by something, by a column in that plot, and then plotting it all for each value that it found in there. So here we found a few values in state. I'm gonna just look at P4 by itself. Right, all the states are mixed in together. Okay. Illinois, Indiana, Michigan, Ohio, Wisconsin, they're all in the same plot. You might want that, but maybe you want it to be easier to see. And so the syntax for that is this nice built-in facet. So P4 plus a new layer, facet, and you see we got a few. Null, that means no facets. Okay, interesting. We got grid, so we can tell it exactly how many rows and columns to divide stuff in, or wrap, which just kind of wraps it, does its best guess. For this class, until you get to like your final project and want to really customize things, that's going to be great. Okay, so we're adding a facet wrap to our plot as a new layer, a transforming layer, and then we say tilde state. Okay. It knows about state because P4 knows that it's working with the Midwest data. Okay, so it knows that there's something called state in there. I can say names Midwest if I want a reminder of all the things in here. So let's try this. Facet wrap. What other column could we facet based on?
Area.
Let's try that. P4 plus facet wrap squiggle area. The squiggle, when you see it, think as a function of. That's what it means. As a function of area. It's going to take a bit of time.
Let's see if you're facet wrapping a continuous variable. Would you be able to bin it?
Let's take a look at it. This is a pretty stupid plot. Because area was continuous, it did bin it, but it binned it into all unique values that it found. It doesn't know to bin it into groupings of areas between this and that. You'd have to set that up yourself. So what it did was for each unique value of area that it found, 0.005, 0.009, 0.01, it made a bin for each one of those. And so this probably was a bad choice. That's fine. Keep in mind that you do have to make a really ugly plot for me, so maybe consider faceting on a continuous variable. Definitely, facets work better with categorical stuff, like state, and they work best when the categories, when there's not like 100 different categories, because then you'd have 100 different plots. So if I do P4 plus facet wrap as a function of state, let's take a look at this. Okay. All the y-axes and x-axes are on the same scales. That works, sort of, but I don't exactly like it. How come? Works really well here for Wisconsin because we get a graph dots basically filling the whole area. But over here in Ohio, right, what's the area? We only go up to 0.4 for the proportion of the maximum area.
So if there is a relationship between area and population, it doesn't show it that well, so you need to.
It doesn't show. I don't think it shows it as well. It's showing it. It's just harder to see. It's maybe condensed and makes, like Indiana, it's making that look like it's a steeper angle than it necessarily needs to be. And so that's why within the facet wrap function, I've tried here, scales equals free. So that's how you get around that. That lets you lets it set the scales for the X and Y axis for each facet separately. So if we do that, you can see that, there we go. Each of these plots is taking up the whole area, but keep in mind that it has changed the axis scales. And so you definitely need to have those numbers, and you may even need to say in like your caption, like Y or x-axis scales vary for each state, just so your readers know to look for that. All right. So we saw a few different things. We know our basic ggplot. We give it a data frame. We give it some aesthetics to pay attention to. You now know that you can do calculations in those, however you want to transform your data. We can add things outside of aesthetics to make it all the same, or inside of aesthetics to make it vary based on a column in your data frame. Okay, so we've seen geome point and geome smooth. But if you remember, we've got a whole list of geomes. So I just want to show you a few more that we can play with. All right. So let's take a look. P5. We're setting this as, whoops, not Z. ggplot. Once again, the Midwest data set. And we're setting some aesthetics here. All right. What are the aesthetics that I've set?
X-axis is going to be the state. The Y is going to be the colleges. And I'm not sure what the fill is for.
Fill is kind of like color, but for big shapes, it'll fill in instead of just changing the color around the outside.
Okay.
Per college is the percent of people with a college degree. Okay. Fill is state, so the color is the fill color will vary based on state. And then I've added some labels, state and percent with college degree. So let's create P5 and take a look at it. Is that unexpected for you?
Yes.
That blank plot. Why is it unexpected? Because
the other one turned out so beautiful. So.
What did we skip making this plot?
The geome, right?
Yeah, no geome. So we told ggplot what data set we're using. We told it X and Y aesthetics. So it made us a nice plotting environment, but we didn't tell it what to draw. All right, so here's geome box plot. This works when your x-axis is categorical, which in our case it is because it's state. Geome box plot. All right. Which state has the greatest percentage of people with a college degree out of these 5?
Wisconsin.
Looks like Wisconsin. It at least has the highest median, okay, for all of its different counties. Here's a violin plot. These are actually a bit more informative, I think, than box plots. Interesting trivia, the violin plot was invented by statisticians at BYU, just down the road. Okay. What is the violin plot showing?
It seems like kind of an alternate version of a box plot almost.
Looks like a sideways. Wow, I just forgot the name of it. Bell curve.
Yeah, sideways bell curve, or as we call it here, a density plot. It is a sideways and reflected. Okay, so it's showing the density. So the width of this refers to the proportion or the density of individuals' observations that have that. So you can see that 10 to 15% here, that's kind of a high density for Illinois, and it tapers off. So there aren't very many counties in Illinois that have over 40% college graduation rates, but there are quite a few that have 15%. And so that's kind of played out the same over all these, right? P5 plus geome density. What's going on there?
Everything became Wisconsin.
They plotted themselves in order, and it's covering up each one successfully. So Wisconsin is blotting out everything else. A violin plot is the way to show density if you've got a categorical x-axis. In this case, it's not working out very well. Okay, so real quick, let me show you another way of looking at the violin plot. So ggplot, mid, west, aesthetic, x equals per college, fill equals state, plus geom density. All right, I'm going to call on Lacey. Describe this plot. What's it showing?
I think it's fairly similar to what you just did, except instead of well, keep going one more. Because it looks like Wisconsin was still, yeah, that one, the bad one. Wisconsin's still overlapping, so it's still in order, but it's just reaching the peaks instead of just filling up the whole graphic.
Yeah, so the violin plot is basically just reflected over that x-axis, and then it's turned 90 degrees to the left and split up. Okay, so this is a density plot showing the distribution of values in each of those states. And obviously it's really hard to see because they're all plotting on top of each other.
Yeah,
so,
just question, why did it pick Wisconsin on top?
Alphabetical.
Oh, okay.
Yeah. We can change that by making it a factor and setting the order of the levels if we wanted to, but by default it goes alphabetical.
Okay.
So let me show you a little trick. Alpha. You're going to want to remember alpha. It works on a scale of 0 to 1, being a saturation of the color. So if I run this, you can see it just adds some transparency, so you can kind of see what's going on in the background. That's kind of handy. But these are all overlapping a whole lot, and so I think violin is probably a better way of showing this. But you note what I had to do differently to get the density plot was to give it the x-axis that's continuous. And you note that I didn't even give it a y-axis. It calculated that on its own. Okay. Let's try this next plot. Geom bar with stat equals identity. Okay. I hate this plot so much. What's wrong?
Well, it looks like it's giving incorrect information.
Why?
I don't know. Compared to all the other plots, we had Wisconsin, right?
Wisconsin was higher.
Oh, yeah, it's showing that Illinois has the very highest percentage, but it's not showing anything about like the population corresponding to that. Is that correct?
What do you know about percentage?
They're always misleading.
No?
It goes from 100% to 0. Is this like a sum of the percentages?
Uh-huh. There's no such thing as, 1,822%, right? Does Illinois really have more college degree holders than it has people? That's not possible. So geom bar is not good for showing things on a percentage scale, right? It is by default doing the sum. So let's see, P5 plus geom bar. Oh, and it says it can only have an X or a Y aesthetic. I got around that by saying the statistic that it should use is identity, but it just summed them together. So geom call. Stat equals, I forgot how to describe this, question mark geom call. Da-da-da. Stat equals count, maybe? Is that right? No, that didn't help. Okay. So how would you fix this? How would you more appropriately display this information if you were trying to tell a story with your data?
I might take the mean of the percentage and display that instead.
So that's essentially what we did here with the box plot. We're showing the median, the first and third quartiles, and some outliers. Okay, so bar plots are for lazy people who don't know how to show statistics. That's my controversial quote of the day. I'm sad this is being recorded because it's on the record now, but when I see a bar plot, it makes me angry. Okay, it makes most data scientists angry because it doesn't show you very much and it's very often misleading. Okay. If you looked through the bad plot examples that I had online, how not to make a chart, okay, definitely look through these. You'll see how bad bar plots are. So before we move on with this new package that contains the Minneapolis police stops, I want you to create a little space here and say data MT cars. Now I want you to make a plot on your own of MT cars with any variables of your choosing using ggplot. I want you to color or fill by some column in the data set. I want one of the columns to be X or Y, and just show me something, anything about this data set. Names MT cars. Okay. If you want to know what the columns actually mean, question MT cars. So there's your info. I'll leave this screen up so you can kind of have it. I don't know if it's easier for you to see this way or on your own. But take the next 10 minutes and make a beautiful plot with ggplot using MT cars data frame. All right. And then you're all going to take turns sharing your screen and describing your plot to me and to the rest of the class. We set? Any questions?
Yeah, on my computer that I'm doing my R programming, my Microsoft Teams isn't loading very well. Like it just doesn't let me sign in.
Oh, how are you talking to us now?
Oh, it's through another computer. I have two.
Okay.
They're both kind of trashy, but anyways.
Gotcha. Okay, so what you can do then is, can you upload stuff to the chat?
Oh, yeah.
All right, so once you get the plot the way you want it,
right,
put that in the chat and I'll run it on my screen.
Oh, okay. Sounds good. Thank you.
All right. So 10 minutes, starting the counter now. know as soon as I find it. Okay. This is your 2-minute warning. This has been your official 2-minute warning. All right. Let's see what you got. I'm just going to go through the list alphabetically by first name, like listed here in teams. So starting with Alex.
How do I share my screen?
There's like a little button next to the microphone on mine.
Oh, okay. Yeah, I got that.
Okay.
Okay. Did that work?
Boom. Miles per gallon versus engine cylinders. Okay.
That's my graph.
And you got a nice little smooth line there.
Yep.
All right.
Pretty simple, straightforward. So it shows a good trend line, you know, more
I'm
cylinders.
curious why you have a legend on there at all.
Well, I didn't add that. I was trying to title it, but when I changed the color in Geom Smooth to red, it automatically added that legend in.
That's because it's inside of an aesthetic.
Gotcha.
So take it outside of an aesthetic, just delete the aesthetic and the little parentheses around the color equals red. Now run it again.
I think it got mad at me.
Scroll over to the right. You got a plus sign there that doesn't lead to anything.
Doesn't lead to anything. There we
So
go.
take out that plus. All right,
I
now
was
run it.
adding more. I
Gotcha.
ran out of time though.
All right, now run it one more time.
Still mad at me. Think. I was trying to mess with the point. Oh no! I made the whole thing go away.
Scroll up in your console a bit. I want to see what error turned up. Unknown color name, black.
Yeah, I was working on. We'll just change this. Gosh, how do I do this?
There you go.
Let's try that. Ah, there we go.
All right.
Hey, no more legend.
Cool. All right. Go ahead and close out your sharing. Carlos, you're up. You have, I thought I saw it in our chat.
Not yet. I'm still trying to load it really quick.
Okay. Cody. Okay. So we've got displacement on the x-axis, miles per gallon on the y, and it's colored by the number of cylinders.
Yeah. Yep. Am I still sharing the screen?
Yeah, it looks
Okay.
good. All right. So that's actually pretty nice. It did 3 separate regressions, one for each number of cylinders. So that's interesting.
Yeah, I turned cylinder into a factor, so
Okay.
that kind of behave like that.
Yep. Where did you turn it into? Oh, there it is. Up.
Oh, yeah.
I see it on line 163. Okay. Yeah, I didn't see it in your code, so.
Oh, yeah.
Looks good. All right, Dalton. Show us what you got.
Okay. So, pretty sure this is redundant because it didn't change it there. But so this is a pretty useless plot that shows you the miles per gallon in relation to carbs.
Okay.
Put a little title there that said that. What I was trying to figure out to do is how do I change the colors to match each carburetor?
Well, it did, in a way.
Or I guess, how do I
But
change the color scheme to be more clear?
carb, as it is it's being interpreted as a continuous variable. So for y equals carb, I want you to wrap that in as dot factor. So y equals as dot factor carb. Nope. Y equals as dot factor carb. Yeah.
As dot factor. And then parentheses carbs.
Yep. Now, also fill equals as dot factor carb. Sorry, not fill, color. Change the word fill to color. Nice.
So it's still rather unclear.
It is.
Does he need to change his
What
palette?
bothers me most about this plot, not the color scheme necessarily, we can work on that.
Is this
But-
the problem?
Yes.
So should I delete?
Just delete that along with that plus sign.
Well, I just got rid of everything.
Oh, yeah, sorry. You have to have the G on point. I thought maybe you had 2 G on points. Okay. And you forgot the plus sign. Okay. Now, maybe this will work.
Hey!
Okay. Okay, so that looks good. What upsets me about this is that you've set up the graph to make it look like the number of miles per gallon could have an influence on the number of carbs in an engine. Does that make sense?
Yeah. Yeah, that's why I put a title in there.
Yeah.
So
Okay, so maybe you were deliberately asking a stupid question. Okay.
Yes.
Typically, the dependent variable, the thing we're interested in, we're going to want to throw on the y-axis. I don't know of any mechanistic explanation for how the number of miles per gallon could affect how many carburetors are there. It's obviously going to be the other way. So keep that in mind. The y-axis is the traditional place for the dependent variable. All right,
Yes.
looks good. All right, Emily, you're up.
Sorry, I'm typing one thing. It kept giving me a box plot, which isn't something I wanted, so I was fixing it.
Okay.
I posted mine on the chat, by the way.
All right, I'll grab it. While I'm waiting for Emily's screen share.
And are you sharing your screen?
No. Who is? I think Dalton is still sharing. Can you close out your screen sharing, Dalton? Okay. Now Emily should be able to. Emily, do we have you there?
Yeah, I'm here. Sorry, my graph is still not working.
All right, we can come back to you.
Okay, thank you.
Ernie.
One sec.
All right.
That's what I have.
Cylinders versus miles per gallon. Okay. Miles per gallon probably should be the y-axis in this case. And then you've set your plot up right. It looks good. What you may want to consider is that cylinders is actually not going to be a continuous variable. I guess, like somebody said in the chat, you're a biologist, you don't know about cars. Anyway, you can't have 1.1 cylinders in an engine. That doesn't work. It's going to be whole numbers, and so treating them as factors or integers is going to be more reasonable, I think.
Okay.
So for your x equals sil, do as dot factor around the sil, and I think that would correct.
Right here?
Yeah.
Wait, what was that again?
As dot factor and wrap it around the sil, not the color part. Yeah. So what we're telling ggplot in essence is color should be not sil by itself, but sil converted to a factor.
Like that?
Yeah, like that.
Okay.
So we're converting it to a factor within ggplot. We're just telling it to interpret things a bit differently. All right, try running that. Okay, so I like the look of that better. So you've got Phil as VS.
He's got miles per gallon against miles per gallon.
There we
Oh,
go.
there we go.
Okay, so what's happening is it's giving you an extra legend called VS. You see that?
Yeah.
When it's not actually doing anything. You don't have any geomes that understand what fill means. Because geome point and geome smooth don't have a fill option. They only have a color option. So what I would do is just erase the comma fill equals VS in the very beginning of your plot. Yeah, line 170. And that'll get rid of that pesky kind of extra. There we go. All right, so this makes intuitive sense to me. Cars with tons of cylinders, big engines, get less or fewer miles per gallon.
How do you change the title for this, the S factor?
Oh, okay, so you've got the labs there, and you've got X and Y and title. Give yourself another comma, and you're just going to call it the aesthetic that you used. In this case, it was color, So color equals
what is it?
Cylinders or whatever you want to call it.
Oh, cool.
Yeah. So ggplot's gonna the labs, the labeling function will look for all of those things. It'll look for an X, Y, title, and color in your aesthetics, and it will give a label to them. So
cool.
Since we made our legend using color, we can label it with color.
Great.
All right, cool. All right, I'm gonna run Carlos's now. So if you'll stop sharing, cool.
So one little thing is that for the colors thing on the, where is it? The Geom Smooth, or no, sorry, what am I talking about? No, Geom Point. I meant to put horsepower, like HP.
Okay.
I mean, but I think that with cylinders, it kind of relates as well. I was just trying to show the the relationship of miles to gallon based on how much horsepower the car has, and I think it does it pretty well. Like it's showing the more miles per gallon is with less horsepower kind of thing.
Let me try wrapping Sil in as factor. Like so. Okay, so like you had originally had it, but as a factor.
Yeah.
So, okay. You're showing, this is nice because we're actually looking at like two different effects on horsepower. We're looking at miles per gallon. We're looking at horsepower and the number of cylinders.
Mm-hmm.
One thing I might do is change the X and Y here to make it a little nicer. Okay. All right.
Okay.
So as we increase horsepower, miles per gallon goes down. That makes sense. As we go from red to green to blue and increasing number of cylinders, we see the same effect. So that's pretty nice. I like it.
Thank you.
So yeah, using your aesthetics like that can be really handy. We can show relationships between more than two variables, independent variables, or more than one, and our dependent variable, in this case, miles per gallon. All right, Emily, are you ready?
Yeah, I have a plot now.
All right, bring it on.
Let's see. Hey, can you see that?
There it is. Yep.
Okay, so actually, funny enough, did the same thing as I think Cody. I did the carburetors.
Okay, so we got number of carbs. You, I think, have color set or fill set to carb instead of color. If you change fill to color, that'll work.
That'll work it. I don't know why it kept giving.
No, you had it right. So Control Z. Now just change the word fill there.
Oh, to color.
To color, yeah. All right, now let's try it. It looks like you've got a dangling plus somewhere.
Plus. Oh, try it right here.
No, that's got labels. Scroll all the way to the right. Okay.
Is it this right here? Because I put colors as factor there as well.
I think that's fine.
Okay.
Try running it again. And now one more time. That kind of just cleared it out. Okay, so scroll to the right.
Okay.
You've got an extra, you're missing a parentheses somewhere. Maybe it's there in the labs.
Okay, let's see. X. Missing a parenthesis?
Mm-hmm. It's kind of hard to see on this one line, which is why I like to break it up.
Between
each plus. So let plus end each line. So right after the plus, not right before it.
Oh.
Control Z again. We'll get you undo. Control Z again. There you go.
And then
So like right after the plus.
Here. That just in there you go. Okay.
And then after that next plus. Okay, so now we're going to be able to see things a little bit better.
Carb factor.
So aesthetics opens, and then you've got x equals as factor carb, y equals mpg, which you don't actually have to put in parentheses. And then color equals as factor carb, which does need to be, and then closes. Okay, then we've got geom point.
Aesthetic. Oh, am I missing one here?
Yep.
I think you're missing
right
one
there.
after carb.
Right after
top.
carb.
Okay, let me try it again. Hang on.
So you're going to have to run it twice.
I'm just think it's not real. I think it's there. Let's try that. What in the world? Okay, now it's just giving me a bunch of pluses.
Yeah. You are missing another parentheses right after the two that are after carb on that second line. Right there.
Right here?
Uh-huh.
I'm missing
See how
another
it kind of highlights? It highlights the matching
okay.
parentheses. So now go left, or one to the right. What?
Okay.
Right there. And you see how it's highlighting that one? So there you go.
Oh, okay.
Now it's closed off.
Now if I click
So
here.
now run it one more time.
Am I missing another one?
I
Sorry.
think you're missing one. I think you're missing one after carb on the first line too.
Yep, you sure are.
Oh.
At the very end.
This one?
Yep. There.
Okay.
See how that kind of, it highlights the one by ggplot. Okay, so now run it twice.
Okay, I'm just gonna go through them all.
This should work. Try a control enter.
Okay.
Bingo.
There we go.
All right, so yeah, lesson here for everybody. If your plot's not working, the likelihood is that you've got either an extra plus that leads to nothing, or you're missing a parentheses. Okay, so we've got number of carburetors affecting miles per gallon. Looks good. All right. Since that's as factor, you could even, since carburetors is actually going to be categorical, and you've set that with as factor carb, you could do like a box plot there instead of geom point.
Oh, I could? Oh,
Yeah, so you could just change the word point in geom point to box plot or even violin.
Okay. Oh, okay.
Yep. Since that X is categorical. Cool.
Awesome. Thank you.
All right. I think we're on Ethan now.
Yeah, I'm still having troubles getting mine to run.
Okay.
I'm just checking through.
I'll come back to you. Josh.
Okay. Oh, I have to accept it wanting to record my screen.
Okay.
Okay, it's saying I have to quit and then get back into it.
Can you just paste your code into the chat?
Yeah. Yep.
All right. All right. While Josh is pasting his code, we'll move on to Lacey.
Okay, last time I was trying to share my screen with you, did the same thing, but I'll give it a try, and I might just have to paste my code also.
Okay.
Oh, maybe it'll work. Okay. Let's try. Is that working?
That works.
Okay, so my code's over here. I also know nothing about cars, so, but I did a graph with miles per gallon versus the gear that is currently in, and I made a violin plot out of it. I couldn't figure out, where do you put color if I wanted to color this?
All right, so what do you want to color it by?
I don't know. I just wanted some
I
color.
guess gear. Okay. So you know how you've got aesthetic right where your cursor is, as factor gear.
Mhm.
Copy the whole as factor gear thing.
Okay.
Right, and then after the y equals mpg, put another comma, and then say color equals, and then paste. That should do it. So now you're coloring by gear. So go ahead and run that, and then there.
There you go. Okay.
If you wanted them filled in, you just change the word color to fill.
Okay. Awesome. So I just have the gears down here that were used, and then it kind of gives you a little density idea of the miles per gallon depending on the gear that the cars were in.
The number of gears that they have. Yeah.
Oh, yeah.
Okay. You also tried something a little weird.
Okay.
After you ran your plot, it said down there in your console in red letters, geom smooth using formula y as a function of x.
Oh, yeah.
But it's not showing up. Can anyone enlighten us as to why?
What was the question? Sorry.
Why did the smooth line not show up on the plot, even though she said geom smooth?
Oh,
It's not a scatter plot, right?
Doesn't have to be a scatter plot, but
it's not a continuous variable.
They have to be continuous. Yep. And so the geom smooth is not ever going to happen if you got a categorical.
Yeah. Okay. So I just delete this whole line.
Yep. Or hit Control Shift C or Command Shift C. Boom. That'll automatically comment out the entire line that you're on. It's a way to kind of delete things without actually removing it if you wanted to see what you tried.
Okay.
Yep.
Also, question. So I just remember that fire brick was a color from last time. How would I pull up a list of other colors I could use instead?
I Google it every single time.
Okay, and then
I Google our color names and they come up.
Oh, yeah. Okay.
All right. I've got Josh's plot here. So if you'll stop sharing your screen, I'll share mine. Okay.
Hey, I actually did the same thing that someone else
I was going to say, this looks
did
familiar.
Previously.
We got horsepower, predicting miles per gallon. We've got a nice trend line there. And the points are colored by cylinder. Right? So you did this in you did it slightly differently. You first created a variable called sil, which is as factor empty cars $sil. Perfectly valid way of doing it. And then for its color, he just said sil. All right. So you could have done that inside the plot or outside like this, just as long as ggplot knows about it somehow. Cool. Okay. Steven.
All right, you can hear me?
Yep.
All right, mine's pretty much exact same as the other two, same as his, because that just seemed like the thing to plot.
Mm-hmm.
Except it's a tiny bit inferior, but let me go over and share it.
I want to see this inferior plot.
It's only letting me share desktop window. This is kind of strange.
All right, paste your code into the chat. I'll run it here. And while you're doing that, Trevor.
All right, I think mine's the same as the last three, but this is mine. Just
yeah.
fuel efficiency.
Number of cylinders, fuel efficiency as a function of engine power, horsepower. Okay. Looks good. So while we're still waiting for Steven's code, was there anyone I missed? I think I got everybody. I'm going to run through this next bit a bit quick because you've already got it written. If you don't have car data installed, you'll just have to install that package. But it brings up, the only reason I brought in this package, car data, is for this data set. This is Minneapolis police stops. Okay. So I'm doing this to show you a few other geomes that you can use. So like geome histogram.
Are you sharing your screen?
No, I'm not. Good call. How about now? Okay. So we've got geome histogram, and this shows us the latitude of police stops in Minneapolis for 2017. All right, this is a real data set. In other words, you do not want to be at 44.95 degrees latitude. You've got a greater chance of being stopped. Okay. What's this plot showing us? Density, so the number of stops that's happening at all of these latitudes, colored by race of the people who were stopped. Okay, here I've got another histogram, but I'm going to do the facet wrap thing. So we're just starting to explore this data set. This is the first thing you do once you get a data set in and nice and cleaned up. You just start making plots because you want to see what's in there. So ggplot's your friend for that. We're doing exploratory data analysis right now. You can have a career in this. Okay. Here I'm going to say X is latitude, Y is longitude. I'm going to look at just a little point plot. So these are all of the police stops in Minneapolis city limits in 2017. What stands out to you? Anyone? What's it look like?
Vomit.
Looks like a street map.
It looks like vomit, and I hope you see streets. Yeah, there's a street map, and what do you think this blank area is right here?
Highway?
That's in the middle of the river.
That's a river.
Okay.
Yeah, so we're getting like a bird's eye view of Minneapolis just by looking at the police stops that were happening. Okay. Just run that same thing again. Oh, this is faceted version. It still kind of looks like vomit, but it's overplotting. Overplotting happens when there's too many points too close together. You can't tell them apart. And so there's ways to kind of get around that. One of those is this idea of a density 2D. So we've got geome density 2D. So let's take a look at that. Any second now. Okay. Any Boy Scouts here? What's this look like?
Looks like a topography map.
Yeah, it's a topo map. And so you can make topo maps in R based on anything. A regular topo map is elevation, right? But here it's the number of police stops in that region, okay, broken up by different races. Okay. So looking at the data set with these tools kind of shows you some of the methods that ggplot has built in just for this exploratory data analysis. Okay. We got about 5 minutes left of class, which is fine. But I would like you to keep playing with ggplot. Use the MT cars data set, use the iris data set. Okay. Let me zoom back up here and just show you what I mean. So I'm going to say data iris, and then I'm going to say ggplot iris. Oh, I forgot the names of the things. Okay. Some aesthetics. X equals sepal length. Y equals sepal width. Color equals species plus geome point plus geome smooth. I'll just leave that at the default. So that's pretty neat. All right, so just a couple short lines of code and we're starting to really get a feel for our data set. Okay. Doing this in Excel is actually a lot harder than this, and it's not reproducible. Right? The benefit of making plots using code is that we're not changing our data, and all of our plots are reproducible. Right? If I wanted to redo this with a subset of iris, so iris is now filter iris species is not equal to Setosa. Run it again. Okay, so my plots are being automatically generated by the code, which is really nice. The last thing I want to show you today is a nice little function called ggsave. It will take the last plot that you ran and showed down here in your box as its default, and you just give it a file name, myplot.png. Done. It's really that simple. You can call this a TIFF, a JPEG, a PNG, a GIF, whatever you want, and it will automatically figure that out from your file extension type and save it as that type of plot. What the advantage this has over the other way is that, first off, it's easier. It calculates all the weird dots per inch and all that stuff automatically, but it also gives us the ability to say how big we want it. All right, so width equals 2, height equals 2, DPI, how much resolution do you want? 100. I'll make it really crappy. So we've got myplot.png. I go looking for it. It's here in desktop. Data course is on. There's myplot.png. And it's real tiny and really crappy. That plot sucks. So I'm going to go back in here and say width equals 6, height equals 6, DPI equals 500. We're going for like publication quality. Can be blown up for a poster. Look, it just overwrote the plot. And there we have it. All right, and we can zoom way in. It still has high res. All right, so ggsave is a nice little tool. Once you've got a plot that you like, run the code for it, and then run ggsave. If I don't want to stick it directly in my data course Zon, what would I change about this?
You give it file directions.
Yeah, I just give it directions. So I just tell it where to put it. Okay. I can even save it outside of my project if I wanted. I could save it to my home directory or straight to my desktop. Okay. Of course, that's not going to work if you're sharing this with somebody else, so you want to keep it within your directory, your R project. Okay. So on Monday, when we meet again, we're going to go over the nitty-gritty of how to change things in your plot, like the size of your font, what font you're using, whether it's italic or bold, how to change the color of the background, change the tick marks, where they're found, how they're displayed, all that kind of stuff. So what I want you to be very comfortable with is essentially what you did today, but to be able to do that in about 1 minute instead of 10 and have it work right.
Okay.
Got a couple questions.
Great.
All right, so the first one is for ggSave, is it just saving the plot that's shown? Because there's like a back arrow that you can just switch between
It's
previous
showing
ones.
the last plot that showed up. The other way to use ggSave is if you name your plots. So I could say this is plot 6, and then I would save plot 6 like that.
Okay. And then the other thing would be, in your global environment, is there a way to selectively delete things that you've assigned?
Yeah, through code. And that's RM, just like in your terminal. And so you just give it the thing that you want to delete, and it disappears.
Nice, thanks.
RM P4. That one's gone now. If you want to give it a big list of things, you can say RM list equals and then concatenate. P2, P3, P5, and it's going to say, oh, what? It wants those as characters. Okay. So really focus. I mean, spend like 3 or 4 good solid hours ggplotting over and over and over, changing things in there, seeing if you can convert stuff to factors. If a weird color is showing up in your legend, I want you to be able to realize really fast that it's because you set it inside of an aesthetic, right? Instead of putting it by itself. Anything in an aesthetic, it's going to try to make a legend for you. So your goal is to be able to basically create a plot like the one you did today in about 1 minute with ggplot. A lofty goal, but achievable. You're going to get there, okay? It will take hours of practice, but I want this to be muscle memory so that when we get into looking at what plots are actually showing us, because we're about to start talking about cleaning data and modeling and all that kind of good stuff, all this statistical business. These plots are going to help us. They're going to help us look at our data really fast and get an idea of what's going on. So you need to be able to kind of throw together a 3-part ggplot like this pretty quickly and know what's going on. All right.
So assignment-wise, what should we be focused on, aside from the practice?
Oh, okay. So go through these resources, okay? Go ahead and install the patchwork and see if you can get that to work. It's pretty easy, but it's got a nice little tutorial that'll get you practice at learning a new package on your own. It's a good one to start with. ggforce, if you want to play with that, this lets you like zoom in on parts of your data set and draw a plot with like a little zoom feature. This tutorial goes through building a ggplot as it changes all the way through, okay? So work through that, do it on your own. So type along with it and see if you can change stuff. As far as homework goes, we've got assignment 6. This is just a ggplot for empty cars like we've done. You're ready for that, okay?
We never did assignment 5.
What's that?
When is assignment 5 due?
Isn't it due already? Didn't we? Did I not assign assignment 5?
No, you didn't.
No, I didn't.
Nope.
Oh.
Yeah, no, not yet.
I'm so sorry. I'm freaking out here. Okay. Work on assignment 5 then.
Okay.
When you get that finished, go ahead and start assignment 6. I think you'll find assignment 6 is actually a bit easier than assignment 5. This one, I'm showing you plots, and I want you to recreate them. All right. For the most part, they're pretty easy until you get to the last one, and it's devious. This is going to take you some time. It's going to involve rearranging things in your plot, but I promise you can find the answer online, and once you do, it's going to really click for you. I will go through it next week, go through assignment 5, but I think you should be able to finish that and start on assignment 6, if not finish assignment 6 by next week, okay? Because assignment 6 is just what we did today. We're looking at empty cars, subsetting it, and then saving a few plots.
When is assignment 5 due?
Since I forgot to actually assign it, we'll make it end of next week, along with assignment 6.
Okay.
Yeah.
Thank you.
My apologies. I thought I'd already covered that. Okay.
And
exam 1, I think most of you are pretty much done, I expect, but Sunday night, I'm just going to do a git poll on your repository and grade what I find.
Okay.
Yep. So focus on getting good at ggplot, or not like you're an expert at it, but like you understand what a plot is doing. If I show you a bit of code with something missing, and you go, oh, why is it not finishing? You should know basically to look for that. The only way that comes around is by doing this dozens and dozens of times. So this is definitely a Karate Kid moment. Wax on, wax off, over and over. Work with Iris, work with empty cars. If you want, the MPLS stops is actually more fun to plot than the others because it has a bunch more fun variables. So play with that if you want. Just play with ggplot, and next week we'll walk through it some more and learn the nitty-gritty of how to change details.
Okay, thank you.
Yeah. Anyone have any concerns about the course pacing or anything so far? We're moving too fast, too slow?
I have a question about one assignment. Can I talk to you afterwards?
Yes, I'll stay around.
Cool.
No, all right, well, adios, everybody. I'll stop the recording.